This video is to show how to use a Excel sheet and set up formulas for the water vapor versus temperature lab. So there's quite a few calculations in this lab, and it's really handy to set up this Excel sheet, and it can automate all the calculations for you if you enter the formulas correctly. So instead of like manually typing in all our values here, we're going to set up formulas, and we're going to use this little function right here where it turns it the mouse cursor turns into a little cross, and then you drag the formula to populate the cells underneath it. So the first formula we're going to do is convert our temperature. So this is the raw data from the lab. These are the values you have. And so the first thing we want to do is, because for the to use the ideal gas law, which is what we're going to use to get, I believe, these values here. To do that, we're going to need our temperatures in Kelvin. So we go here, and instead of typing in a value, we're going to type in the equal sign, and then we're going to type in our math function. So we want it to be 80 plus 273. But instead of typing 80, I'm going to type in the cell A2. So I'm going to type in A2, and then plus. So I have to hit Shift and the plus equal sign key, or that's at least the layout on my keyboard, and then the number 273. And when I hit equals, it automatically adds the 273 to 80 because I told it to do it to A2. Now, if I drag this, what Excel is going to do is it's going to change the function to be A3 plus 273, then A4 plus 273, and it's going to fill in B3 through B9 when I do that. So all I have to do is drag this down, and then it automatically added 273 to each of these numbers. So now, also for the ideal gas law, we want our volumes to be in liters, and we were measuring milliliters in the lab. So don't copy any of this data. These are just fake values that I came up with. So what I want to do is divide each of these by 1,000. So I'm going to type in equals. So you always begin the function by typing in equals. I'm going to take, instead of typing 9.18, I'm going to type in that cell that 9.18 is in, so that it's in cell C2. So you always type in the column first and then the row. So cell C2, so I'll go capital C, then 2, and then divide is the backslash, so divided by 1,000, enter. Okay, and now that is in cell C2 is represented in liters in cell D2. So to populate D3 through D9, I'm going to drag this and go like that. So now our lab, we're not going to do the corrected volume. The reason for that is because of the meniscus, but we used polyethylene graduated cylinders. So those didn't really make like a really curved meniscus. So we're just gonna use these values here for our ideal gas law. Now, I wanted these values. You need to do these two values before you begin this setup here. So you need to actually have these calculated. Refer to the instructions I posted for calculating these numbers. But just to summarize, P cylinder is P total. I was calling it P total in my instructions. It's P atmosphere. So, which is what we measured today in class, and I'll put that on the school website. The value that I actually used a weather app to get that number, and then I converted it to mmHg. The weather app was giving me millibars, so I converted that to mmHg. Not only that, but I added the height of the water column. So again, refer to the instructions I posted, because you need to have this number before you begin doing the rest of these cells here, before we populate the rest of these cells. You also need this number here. So this number is, and again, go look at the instructions I posted, but this one is, it's the moles of air. So you get this by taking P times V divided by RT, and you want Yeah, that's correct. PV divided by RT. And you want to use the volume that you measured at the lowest. So you actually want to use this volume right here. And you also want to use this temperature. So how many moles of air were there when it was this temperature and this volumes? That was the whole reason why you threw all that ice in the beaker, was to basically neglect any water vapor was present and just get the air. So anyway, you'll need to calculate that manually, this number right here and this number. So once you have those two values, you can begin getting the rest of these. So I'm gonna skip this column because we're not doing that. Now P air is gonna be equal to so P air is going to be equal to N moles of air, which is this value right here. This is going to be the same for all the cells here, your moles of air, and times R. And we're going to use R in terms of mmHg. I know it's weird, but all you need to do is, it's listed in the instructions, 62.4 mmHg. And because we want to keep everything in torr, because when we take the natural log at the end, we want torr or mmHg and not atmosphere. So just to keep everything in mmHg, I'm going to switch R. Instead of 0.0821, I'm going to use 62.4. So it's N air times R times T, each one of these T's actually, and the volume at that temperature divided by the volume at that temperature. So instead of, doing that manually, this is the whole reason we're doing the Excel sheet, is we're going to do a formula for cell F2. So I'm going to write equals right here. So I'm going to write equals, parentheses, and now here's a kind of like a quirk about Excel is you want this number to be static right here. You want this to stay still. Otherwise, if you drag and drop like you did before, it's going to try, Excel will try to use the value in B16, B17, B18 these to populate these when you drag and drop. We don't want it to do that because obviously there's nothing here in these cells right here. So to keep it static so that Excel references only cell B15 for all of these, what we're going to do is put a $sign in front of the B and a $sign in front of the 15. And then now it should work. It'll keep this number static instead of thinking to use these values. So, which is what we want it to do. So, and now we're going to multiply that by R. So to multiply, we're going to use the asterisk, and then R, we're going to use the value 62.4. That's the converted R for mmHg, and then we're going to use multiply that by the temperature in B2. And this one, we do want Excel to use B3, B4, and so on when we drag these values. So I'm going to go ahead and enter B2. I'm not going to enter 353. I'm going to actually enter the row and the column and row B2. Okay, and then I want to close the parentheses and divide that by the volume at this temperature, which is, and we want to make sure we want to use the liter one. So I'm going to hit divided by D2. So I'm going to hit D2 right here, and then enter, and then Excel did the formula for me. So now when I highlight, Excel will keep this number static, and it's going to use B3 and D3 and so on to populate these cells right here. So drag and drop, and then it did all the calculations for me. Now for P water, we want to subtract P air from the P total or P cylinder. So we want to use this value and subtract these values. So we're going to do another formula here, and we're going to write equals. And I want to keep this number static again. We don't want Excel to try to use these values. So I'm going to do that by doing the $sign, then A, then another $sign, then 15, and then minus the values in the F column. So I'm going to call it F2, and then Excel will know to do the rest, and then hit enter so that it calculates it. So now I'm going to drag this and release the mouse, and then I have my values there. And now I want to take the natural log of all those values in this column. So I'm going to go here, and then I'm going to click on this fx to insert function, and Excel has a whole database of functions here. So it knows I want to do ln because it remembers. I was playing around with this earlier, and it kind of remembers. But if you want to search for something, you just type in natural log, and it shows you all the different logs it can do. So I want to do natural log. I'm going to hit OK. Now it's asking me for a number, but I want to do all of these numbers. So I'm gonna type in G2 right here in here. So I'm gonna go G2 and then enter. And then it took the natural log of this number here. So to apply that to the rest of these, I'm gonna highlight and then do that. And then here we just do the inverse temperature. So I'm gonna go equals 1 divided by I want the inverse of column B, so I'm going to go B2 here and then hit equals, and then so do that for all of them, and then I have my values. So this is where I'm going to grab. This is what I want to grab. I want to get these, and now I want let's see, what do we want? We want the temperatures on the x-axis, and we want the vapor pressure on the y-axis. Excel by default is going to do this on the x and the y, and I'll show you how you can switch it. So I'm gonna highlight what I want to graph. I'm gonna go insert, and then I'm gonna do an XY scatter plot. This one right here. Now my axes are inverted. I want them swapped. So what I'm gonna do now is I'm gonna tell it to. You have to tell Excel to like swap these. So I'm going to go here and go select data because it selected them incorrectly. So what I'm going to do now is I'm going to go to edit, and it says select range. So I hit this select data, and this box opens up. So now I'm going to select edit. I'm going to highlight these because see how these dotted lines are going around. It's telling me it's plotting the x, these natural log data values in the x-axis, and I don't want that. So I'm going to highlight this. I'm going to highlight that and delete it. I'm going to hit delete. Now I'm going to press this arrow, and I'm going to highlight these. And then once I highlight those, I'm going to hit enter. And now it's putting the inverse temperatures on the x-axis, which is what I want. I'm going to do the same thing for the y values. Select those, delete them, press that, and then I'm going to select these to force Excel to put these on the y-axis. And then once you do that, you have to hit enter. And now I swap the two. Okay. So click OK, and this is the graph I want. So now what I want to do is add a trend line because I want the equation for this line because I want to know what the slope is. So I right click on any one of these data points, and then I find this menu comes up, add trend line, and Excel knows I want it linear because it kind of knows that it's linear. So it's already should be linear here. And then I'm going to put display equation on chart. And this might also be very useful for error analysis, is to display the r² value, because r² value can tell you just how linear your line is. So it might help with some error analysis. So we have a pretty really good line with this data actually. So here's what I want. So and then you could set this equal to take the negative value of your slope and set it equal to delta Hvap over R, and we want to use the energy version of form of R, and then you could solve for delta Hvap. So you would take this, and go. Let's see if I can ink on here. So you would go negative 4,641, you want to make it negative. So it's negative slope equals delta H VAP over R over 8.314 kilojoules per mole. And if you do this calculation, you get like 38,500. which is equal to 1, 2, 3, 38.5 kilojoules per mole, which is pretty close. The actual value was 40.7. And when we get to class, and we see what your group members what they all got, then we could start talking about like where the errors were coming from in the lab. All right, so hopefully that works. It's really handy. You saw how automated it is once you know how to enter the formulas and like assign the correct cells in the formulas, and you could see how handy how powerful a tool Excel can be. All right, so good luck with that. Let me know if you have any questions. You could email me. All right, see you guys tomorrow.